Today we start new chapter, linear programming problems. So you familiar with the word linear. Then we see first topic, linear inequations in two variables. So first we discuss linear equations in two variables. So in class 10 you solve the simultaneous equations. For example, 2x plus 3y is equals to 2, 4x plus 5y is equals to minus 7. These two are linear equations because here equality sign is used. So these two equations are linear equations. Why we call this as a linear equations? Because the power of this variable x and variable y is 1. So this is linear equations. Here two variables are used. So this is also called linear equation in two variables. We know that when line is parallel to any coordinate axis, x or y, we can write as x is equal to a, y is equal to b. This is a linear equation in one variable. So we have to discuss here linear inequations in two variables. That means instead of this equality, if we use relational operators, that is greater than, less than, greater or equal to, less or equal to, we know the relational operators, greater than, strictly less than, greater than or equals to, less than or equals to, or this we write as greater or equals to, less or equals to. Now when we use these relational operators, then that equations are called linear inequations. So instead of this equality, if we use 2x plus 3y greater than 2, then this is linear inequation. Or you can use this as x plus 3y strictly less than 2, 2x plus 3y greater or equals to 2, 2x plus 3y less or equals to 2. These all are examples of linear inequations in two variables. So you draw the graph, or you can find the solution of linear equations by using Cramer's rule. You also draw a graph for the given lines. If the given equation represents a line, then you draw a line. With the help of this given equation, you find two coordinates on that line and plot a point on the graph, and you draw the line passing through that 2 points. Here we have to find the solution of these linear inequations. Means we have to find values of these variable x and y which will satisfy this condition. That means when we find a value, and if that value satisfies this condition, if we substitute x equals to 1, y is equals to 5. If this condition is satisfied, then we say that these values are the solution of this linear inequation. See, when we substitute x by 1, so we get 2 into 1, so we consider here LHS is equals to 2 into 1 plus 3 into 5. So 2 into 1 is 2, 3 into 5 is 15, so we get 17, and we know that 17 is greater than 2. Therefore 17 greater than 2 means condition is satisfied. So x equals to 1 and y equals to 5 is the solution of this linear inequation. If we consider this second equation, then we say that this 17 is less than 2. That is not possible. So we write here this x equals to 1, y equals to 5 is not solution of this second inequation. So in this way we can check whether the given values are the equations of that given linear inequation or not. So from about discussion we say, now see here, the relation ax plus by strictly less than c ax plus by less or equals to c, ax plus by strictly greater than c, and ax plus by greater or equals to c, where a, b, c are real constants and both a and b are not zero simultaneously, are called linear inequation in two variables. Variables are x and y. For example, 2x plus y strictly less than 3, x plus 4y less or equals to 7, and you can take this for example also as a example of linear inequations in two variables. Now we see next topic, solution of linear inequations. Now next topic, solution of linear inequations in two variables. That means if we consider here this equation ax plus by less than c, if we substitute the value of x and y, if that value satisfies this inequation, then that values are the solution of this linear inequation. So see by statement, if a value alpha of x and a value beta of y are such that a alpha plus b beta less than c, that means when we replace the value of x by alpha and value of y by beta, and if this inequation condition of this inequality is satisfied, then we say that that value are the solutions. So see here, then the order pair alpha beta is said to be satisfy the inequation ax plus by less than c, and alpha beta is called a solution of inequation ax plus by less than c. Now these values are infinite. So we write here the set of all solutions of an inequation is an infinite set. So this note we will discuss while solving the problem. You will clear that from one example. So we take one activity. With the help of this activity, you will clear whether the given value is solution of that inequation or not. So see here question. Check which of the following order pair is a solution of 2x plus 3y minus 6 less or equal to 0. So you can write this in this form also, that is 2x plus 3y less or equal to 6. When we transfer this minus 6 to right hand side, you can check with this inequation also. So we check first value. These examples are same as the examples you solved in class 10. You have provided two values. Suppose equation is 2x plus 3y is equal to 6, and you have given two values, x is equal to 1, y is equal to minus 1. Then you have to check after substituting this value, if LHS equals to RHS, then in that case you say that values are the solution of that equation. Here same, we have to check this inequality. So see the first inequality here. So we take first order pair 1 minus 1. That means x is equal to 1, y is equal to minus 1. So we consider here 2x plus 3y minus 6 less or equal to 0. So we substitute x as 1 and this y as minus 1. So we consider here LHS. So LHS is equal to 2 into this value of x we replace by 1, so we write 2 into 1 plus 3 into value of y we replace by minus 1 and this minus 6 as it is, which is equal to 2 into 1 is 2, 3 into minus 1 is minus 3 and minus 6 as it is. So we get here minus 3 minus 6 minus 9 plus 2 which is minus 7, and we know that this minus 7 is less or equals to, so this minus 7 is less or equals to 0. That means condition is satisfied, and from this we say that this 1 minus 1 is a solution of this 2x plus 3y minus 6 less or equals to 0. Now here two conditions are given. That means we have to check minus 7 is strictly less than 0 or minus 7 is equal to 0. That means here we have to check these two conditions, and here word is or. That means any one condition we require. So minus 7 is less than 0 and minus 7 not equal to 0, and because of word or we require only one condition. Here this minus 7 is less than 0, so condition is satisfied. So we call this 1 minus 1 is a solution of 2x plus 3y minus 6 less or equals to 0. Second order pair 2 1. So 2x plus 3y minus 6 less or equal to 0. That means we have to check whether the given value is equals to 0 or less than 0. These two conditions we have to check here. So we calculate LHS. LHS is equals to 2 into, replace the value of x by 2. So 2 into 2 plus 3 into, replace the value of y by 1, and this minus 6 as it is. So 2 into 2 4, 3 into 1 3, minus 6 which is equals to 4 plus 3 is 7, 7 minus 6 which is equals to 1. And we know that 1 is not equal to 0, 1 is not equal to 0, that means first condition is not satisfied, and 1 is not less than 0, that means both the conditions are not satisfied. Therefore this order pair 2 1 is not a solution of 2x plus 3y minus 6 less or equals to 0. Now see third order pair minus 2 1, minus 2 1. So we substitute here x as minus 2. So 2 into minus 2 plus 3 into y as 1 minus 6. So 2 into minus 2 we get minus 4 plus 3 into 1 is 3 minus 6. So we get here minus 4 plus 3 is minus 1, minus 1 minus 6 which is minus 7. And we know that this minus 7 is less than 0. So from this we say this order pair minus 2 1 is a solution of 2x plus 3y minus 6 less or equals to 0. Now we check fourth order pair minus 1 minus 2. So we substitute in this inequation x as minus 1. So we write 2 into minus 1 plus 3 into minus 2 minus 6. So 2 into minus 1 is minus 2, 3 into minus 2 is minus 6, minus 6. So we write this as minus 12 minus 2, that is minus 14. And we know that minus 14 is less than 0. Therefore minus 14 is less than 0. That means condition is satisfied, that is inequality is satisfied. So we say this order pair minus 1 minus 2 is a solution of 2x plus 3y minus 6 less or equals to 0. Now we check the last order pair. So substitute x as minus 3. So 2 into minus 3 plus y as 4 minus 6 as it is. So 2 into minus 3 we get minus 6, 3 into 4 we get 12, minus 6, minus 6 minus 6 that is minus 12. So 12 minus 12 which is equals to 0. So this first condition is satisfied. We know that 0 equals to 0. So condition of this inequation is satisfied. So we say order pair minus 3 4 is a solution of 2x plus 3y minus 6 less or equal to 0. Now if you observe, we consider here high order pair, and these first, third, fourth, fifth, this 4 order pair satisfy this inequality. So you can take more than 1 order pair, that means we get infinite solution for the given linear inequation. Now see next topic, convex set. So you already studied a Venn diagram when we represent a set in closed curve. If more than 2 sets are given, suppose set A and B, their intersection we represent by A intersection B, their union we represent by in this way. These are the 2 Venn diagrams. Now here we have to discuss convex sets. Now if we consider set S and capital A, capital B are 2 distinct points of set S. Now when we join these 2 distinct points, if the segment joining these 2 points wholly lie in the set S, then we call that set as convex set. Now see here, suppose this is set S. We consider here point A and point B, which are 2 distinct points of this set S. If we join these 2 points A and B by a segment, if this segment wholly lie in this set S, then this is convex set. If we consider instead of this closed curve like this, and this point A is, and if we join these 2 points, this segment AB is not wholly lie in this set S, that means this set S1 is not convex set. So this set S is convex set, this set S1 is not convex set. So we write the definition of convex set. Let S be a set of points and AB be any 2 distinct points of S. If the line segment joining the point A and B lies wholly in S, then the set S is called convex set. So with the help of this figure, we say whether the given convex set is bounded or unbounded. Bounded means closed and unbounded means one portion is open. So see here, this polygon is closed, this quadrilateral is closed, this circle is closed. So these 3, first, second, third are bounded convex sets, and these 4, 5, 6 are the unbounded convex sets. So we will discuss this while solving the problems.